Hello learner, welcome again to Manifested e-learning platform. My name is James Kenyani. We are coming to some of the winding sessions of lessons of rotation, and in today's lesson we are going to look at rotational symmetry of solid shapes. So at the end of the lesson, as an objective, the learner should be able to identify the rotational symmetry order of some solids he would be given. So you should be able to identify the rotational symmetry order of solids. So the word order comes, you should move the solid through 360 degrees. So straight to our figure A, learner, if you look at figure A, we have a triangular based prism whose cross-section is an equilateral triangle, So we have some axes there. You can see a vertical axis and 3 horizontal axes. There is something there. They have told you it has a horizontal, it has a cross-sectional area, cross-sectional section of an equilateral triangle. At this stage, you know what an equilateral triangle is. An equilateral triangle will have all the sides equal. It will have all the sides equal. And when we are talking about the lines of symmetry, we noticed it had 3 lines of symmetry. It had 3 lines of symmetry. And this center was found where lines were drawn from the vertice to the median of each side. That's where you got that intersection. So from that intersection, we had 3, you can see 3 horizontal axes, 3 horizontal axes, 3 horizontal axes. When I talk of 3 horizontal axes, 3 horizontal axes, they'll have which order? They'll have which rotational order? Because if I have one vertical, it will rotate in a horizontal manner. If I have a vertical axis, it rotates in a horizontal manner. If I have a horizontal axis, what happens? It means if I turn, I can turn these clockwise and anti-clockwise. So a half turn, it will map onto itself. 360 degrees, it will map onto itself twice. So I can say in A, this figure, in the prism, then the prism has 3 horizontal axes, each of rotational symmetry 2, rotational order 2, each of rotational order 2. What does that mean? If you rotate that prism, after half turn, it will map onto itself. Turn again, 360, it will map onto itself. This will happen when in each of those axes, you realize one of the axes is from this corner to the center of the other face, from this corner to the center of the other face, and from that corner to the center of the three faces. So it has three of those faces which are rectangular. So one of the axes is from this corner to the center of that rectangular face. So the prism has three horizontal axes, each of rotational order 2, meaning if you rotate half turn, it will map onto itself. Another 180 to complete that, it will map onto itself. And there is a vertical axis there, and it also has, or you can complete that by saying, and a vertical axis AB of rotational order, let's see the order now. It is that axis. When we have a rotation along that, it will mean this prism will map onto itself 3 times before it completes the 360 degrees. After 120 degrees, you'll find it maps onto itself. 240 degrees maps onto itself. 360 degrees, the final mapping. So it has a vertical axis AB of order 3. It has a vertical axis AB of rotational order 3. On that axis, when you rotate, the prism can map onto itself 3 times. We move to B. In B, you notice we have a right pyramid whose base is a rectangular hexagon. It is not the first time we are meeting a hexagon. In the previous lesson, we learned that any polygon will have the number of lines of symmetry equal to the number of sides. So a hexagon having 6 will have 6. That will lead to us discovering how many orders of rotational symmetry it will have. So we have the vertex at the top, and the vertex meets that perpendicular. So you can say the right pyramid above So we go back to what is going to happen. If you rotate 60, like in the previous lesson, you'll find the hexagon will map onto itself. By the time it completes the 360 degrees, it would have mapped onto itself 6 times. So you can say the right pyramid above has rotational order 6 about axis AB. You notice that the shape of the base contributes a lot to knowing what will be the rotational order of that. So we come and say also that all solids have a rotational order of 1. A solid is said to have rotational symmetry if it has an axis which has an order more than one. Like this one has rotational symmetry, if that one, and that also this one, because there is at least an axis having more than one order. It has an axis having more than one order. So at the end we can compare congruence and rotation. In rotation, the lines and the angles are invariant, or they remain the same, which means the size and the shape, meaning that the size and the shape remain the same, meaning that the size and the shape remain the same. So in rotation, so it means in rotation the lines and angles remain the same, meaning that the shape and size, which relates to area and volume, remain the same for the object and the image. This is a clear indication showing that the object and the image are congruent. In rotation, the object and the image are what we call congruent. Are congruent. For a reason mentioned above. The lines and the angles remain the same. The shape and size remain the same. But earlier on, we had direct congruence and opposite congruence. So since in rotation, the object can be mapped onto the image without turning it over, we call these as earlier learned direct congruence. You learned this in the previous lessons. We call this direct congruence because you can map the object onto the image without turning it over. We've got indirect congruence in reflection, but there was a special case of reflection, multiple reflection, which resulted into direct congruence. So that leads to direct congruence. So there is a direct relationship between congruence and rotation. Most of the images that you'll get in rotation, they'll be the same as the object in size and shape. And the object can be mapped onto the images without turning over. So that's why we call it direct congruence. So learner, check wherever we've gone, the shapes gave us the axis of symmetry, and order comes from turning through 360 degrees. If you find it is 2 times, it gives us an order 2. If it is 3 times, order 3. So as we wind up on our congruency, it's a good time for us to get an assignment. The assignment is mathematics for Kenyan schools. For Kenya schools by Patel. Exercise 6.2. Exercise 6.2, number 9 and number 10. For those who don't know Patel, I'll give you Patel book 2. This is the book in which you'll get that assignment. So work the assignment as you go through the concepts of rotation, as you experience them in life and everywhere. Get the concept and work out the solutions for the 2 sums correctly. So thank you very much for being with me through this lesson and the topic rotation. Let's hope to meet in the next lesson. So thank you and bye-bye.